So it's day 2 of our sourdough journey. It's exactly been 12 hours since we made the leaven last night. Let's check it out and see where we are. Okay, so the room temperature last night was exactly 65 degrees. It's winter here in Cleveland. Temperature went down to 65, so I'm just going to test the dough temperature. It's the first thing I do. And the leaven temperature is about 66.3 degrees. So I can assume that it was around 65 degrees last night. My thermostat just kicked down this morning and maybe brought it up 1 degree. There's a little bit of a dark crust on the top of this, which is not uncommon. It just dried out a little bit on top because I just put this towel over it. I could have put a plastic wrap or something over it, which would have kept that browning from doing that. So now we're going to size up the leaven and see where we are. The first thing that we want to do is smell it. It still smells pretty young and pretty fresh. I'm not smelling much of the acidic smell at all. I'm smelling a yeasty, floury smell. So I'm going to just stir this up a little bit and see what's happening here. And you can see it's starting to get stringy. Just stirring in that harder crust that formed on the top. It's a little bit stringy, but this still has a little ways to go. Now, how do I know that? Because I compare this to my starter. So here's my starter. Now this has been going almost 20 hours since I last fed this yesterday, but you can see that the starter is very liquid, very stringy, much more liquid froth to it. And we don't want the leaven to become like the starter. It's not expected to do that. It should be in what Chad Robertson calls a younger stage, because this is more acidic and alcohol smelling. So we want the leaven to be, essentially what he would call a young leaven. This is close, but it's got a little ways to go. So I'm going to give this another hour or two at room temperature. Now that my heat is back on, this will come up and speed up the process a little bit, and we'll check this in another hour. It's been 1 hour since we checked our leaven, and I just wanted to pause here and describe how did I know that the leaven wasn't ready? Because this is what's frustrating about a lot of these how-to videos is you say, well, how am I supposed to know this? This person's an expert. They could immediately tell it wasn't ready. I'm not an expert. How am I supposed to know? I knew because of what the book told me. So I go back to the recipe, and it says that in the morning when you check your leaven, and I'll just remind you that the book and the process, the recipe, does not tell you how long to let the leaven go. It just says overnight. So I approximated 12 hours, so I know that the time could be a variable that could go either direction. But in the book, Chad Robertson gives you basically 3 tests to determine if your leaven is ready. The first one, which I did first, was the smell. He said your leaven should smell sweet in an overripe fruit sort of way. I smelled the leaven. It didn't smell like overripe fruit at all. It smelled like flour. So I could tell that it just wasn't quite active yet from the smell. So that was test number 1. Test number 2 was just looking at it. The book says that it should increase in volume by about 20%. And I could see that it had developed that hard crust over the top because it had gotten a little bit dehydrated in the night, and it hadn't risen at all from when I put it in this bowl last night. And I did transfer this from a large glass bowl into a smaller glass bowl, which was not on the video last night. But I could tell where it started, and I actually put a piece of tape on this side, which you can't see, to determine what my starting point was, and the leaven had not risen by 20%. So those were two tests that failed. The third test that we could do, which we'll do here momentarily, is a float test where you take a small spoonful of the leaven, put it in water, and see if it floats, and that'll give you an idea of whether or not there's enough CO2 that's aerated the dough, and that indicates how active the yeast has been. So based on the failure of those first 2 of 3 tests and not conducting the third test, I determined to let this go another hour. And this is a great example of how this process works. The ingredients in the process, the water, the flour, and the starter, are only a piece of the equation, And you also really have to be able to manage the temperature and the time, because those are the only two variables that we have available now, because I can't change the ingredients. We measured all the ingredients exactly, but we're running a biological process here, and it's going to run on its own time occasionally. So you have to use these other indicators to determine when it's done, and then you use time and temperature to influence it. So the fourth common mistake beginners make when they're baking sourdough bread is failure to monitor the time and temperature of the process. When you think about sourdough bread baking, some people ask the question, how complicated can it be? There are only 3 ingredients: flour, water, and salt. There are actually more than 3 ingredients. There's flour, water, salt, and your starter. Your starter has 2 microscopic ingredients in it: yeast and the lactic acid bacteria. So that's up to 5 ingredients now: flour, water, salt, yeast, and lactic acid bacteria. So I'm up to 5, but there are actually 2 other ingredients in sourdough: time and temperature. When you're making sourdough, the recipe is not just the ingredients that you're putting into it. The process also includes accurate measurement of the time and the temperature because of the fermentation that you're doing with the starter ingredients. These are the invisible ingredients that you can't really measure what's happening with the yeast and the lactic acid bacteria, but you can measure the time and temperature of your dough and the process, and that's how we approximate what's happening with these. So there are actually 7 ingredients in sourdough bread, and that's the way you have to think of it: flour, water, salt, yeast, lactic acid bacteria, temperature, and time. Now, why is this important? I'll show you one example. When I was reading this Chad Robertson's book about the Tartine method, and he talks about his recipe, he gives specific temperatures: water temperature, internal dough temperature, and he gives one example here in the book where he says when he was baking bread in his bakery that if he reduced the water temperature that he was adding to his dough by 1 to 2 degrees Fahrenheit, it would lengthen the fermentation process, or the bulk fermentation process, by 1.5 to 2 hours. So just think about that. So you're trying to follow a recipe. It says your bulk fermentation should be 3 to 4 hours. I made the same mistake myself. I'm measuring the clock. I have my timer going. I measure it out to 4 hours, but what I wasn't measuring was the dough temperature. And he specifically says that the internal dough temperature should be between 78 and 82 degrees. The room temperature of my house was 72 degrees maybe. My dough was roughly 72 degrees, so my dough was under fermented because I wasn't measuring the temperature, I was only measuring the time. And then there are other examples where if the temperature is higher or lower than the target, you can adjust the time to compensate for that. We'll go through this in much more detail as we go through the baking process. But remember that you need to accurately measure time and temperature. You need a probe thermometer, one of these you can buy at a kitchen store. I have these ambient room thermometers. These are $2.50 a piece on the internet. You can use, I keep one of these with my starter at all times, so I know what my starter temperature is. You can keep one on your countertop, so you know what your countertop temperature is. I keep one inside my refrigerator when I do my overnight proofing, so I know what my refrigerator temperature is. So it's very important to know your temperature. We'll show examples throughout the process of how we do that. So based on the importance of measuring the time and temperature, I knew that this needed a little bit more time. So now when we look at this compared to before, I can see, so I'll do the first thing is the visual test and say, did this increase in size by 20%? I have some tape on the side of the bowl here where the leaven was last night. And by looking at it, it's up about 10%. And you can also see from the dough that it basically has shoulders around the edges. This is a good way to see if your dough is rising in the bowl or your leaven is rising in the bowl, is that if you look around the edge of the bowl, you can see that it's doming up in the middle. And that means that there is air building up, there's CO2 building up inside, and it's pushing the dough up. From when we looked at it an hour ago, you can also see there are bubbles on the top. We didn't see any bubbles before, so this is definitely fermenting. It's very active because you're seeing the bubbles here, so that means that the yeast is generating carbon dioxide. So that's a good sign that our starter is working, that we didn't have a bad starter or an immature starter. So we're getting some CO2 activity in the dough. And then the third test that we can do is the float test. So I'll take a cup of water, room temperature. You take a small amount of the leaven, and we put this into the water to see if it floats. And it does. So the leaven passed the float test. So what that means is that the lactic acid bacteria and the yeast has fermented enough to generate enough CO2 to basically carry the weight of the flour in a cup of water. So I passed the float test. I've increased in size by about 10%, even though the book says it should increase by about 20%. And then I do the smell test. This does smell a little bit like a ripe cantaloupe. So I'm starting to get that ripe fruity smell. The floury smell that I smelled an hour ago, I could smell the raw wheat flour, is gone now, so I'm definitely moving in the right direction. But I still think this needs a little bit more time. So we passed one of the three tests. We passed the float test. It's starting to get that ripe fruity smell. I can definitely smell those notes in here, and it's increasing in size. You can see the bubbles. I'm going to give this a little bit more time. We'll check it in 30 minutes. So we have to decide what to do here. This is a challenge, but this is the reality of sourdough bread baking, is that you never really know how it's going to work out. So we'll assess our options and decide what to do. There's always a temptation at this point just to press forward and say, oh, it'll be fine, let's move on, ignore the facts of what we're seeing here before us. So I'll consult the recipe and decide where we go from here. Okay, we're moving on to the next step, which is mixing the dough. So I consult my recipe, and we basically need our leaven, water, and flour for this step in the process. Then we'll add the salt a little bit later. So I like to pre-measure the ingredients. So I already measured out 900 grams of bread flour and 100 grams of whole wheat flour, and I've mixed those together in this bowl. I have about 1 liter, 1,000 grams of water in this pitcher, which I've heated up to 80 degrees, which is what the recipe calls for. I put that in the microwave, and that is exactly 80.2 degrees. So that's very close. So we're going to go with that. I've also measured out 20 grams of salt. It's very important to measure out your salt in advance, because sometimes you get caught up in the process and forget to add the salt. That just happens all the time. I don't know why, but many people make that mistake of just kind of moving on and forgetting about the salt. So let's briefly talk about the leaven as it goes into the recipe. So this is one of the most confusing parts of the recipe in the Tartine bread book, because the method that Chad Robertson uses to create the leaven is that you basically create 400 grams of leaven, but you're only using 200 grams of it in the recipe. And then he assumes that you're taking the other 200 grams and using that for your starter. So you're basically pitching your old starter that you created this with, and you're using this fresh starter, half of what's left here, the 200 grams, for your starter for the next batch. So it's just the way that he does that in his bakery, but it's very confusing because I have all the ingredients laid out here, and a mistake that a lot of beginners make is they add all the leaven to this recipe when in fact it only calls for half. So be very careful about reading the recipe and only including 200 grams of the leaven. Once you get into the process, and if you're not actually using this method of keeping the extra 200 grams as your starter, you can just make 200 grams of leaven to begin with, because I mean, I'm going to be discarding 200 grams of this. I just did it so that we could follow the recipe, so that I wouldn't skip the step of telling you not to cut that in half, because it's very important. A lot of people make that mistake, but I don't have the need for another 200 grams because I already have my starter going in advance. What you can do is you can dry this out and save it for a backup starter. And here's one that I did a couple of days ago. I took some excess starter that I had. You spread it on parchment paper and let it dry out for a couple of days. And then you can put this in a sealed jar and keep this as your backup starter. You can rehydrate this, you know, in the future. Some people say, well, how long would the dehydrated starter last? The answer is a very long time. There's evidence that they found, there's an example where they found some dehydrated starter in Egypt, and they believe it was 4,500 years old. They reactivated that, rehydrated it, and basically baked bread with 4,500-year-old dried out starter. So that starter might last 4,500 years, I don't know. Make sure you put the date on it in case somebody finds it in the distant future. So let's start to mix up the ingredients here. So we'll start with the leaven and the water. So again, just to remind you one more time, is you only use half of the leaven that you just made. We made 400 grams. The recipe calls for 200 grams to be added to the dough. Very, very common mistake people make is dumping the whole thing in, and that will really ruin your loaf. As I'm looking at this leaven right now, it actually looks pretty good. So that longer time, I believe, worked. I guess we'll see in the end if it did. But it's a great example of why you have to be patient. You can't really push forward and just try to move ahead with the process. We took an extra 2 hours to get this in shape. 193 grams. Let me get a little bit more in here. 206. This is always tough to hit this exactly at 200. 201. I'm going to go with that. This is my leftover leaven, which I can use as a starter. I could create another batch of starter. I could dehydrate this. This actually looks pretty good. So I'm happy with how it came out. I think that's going to work. Okay, then to the 200 grams of leaven, we're going to add 700 grams of water at 80 degrees. So I heated this up in the microwave. It's exactly 80 degrees. I'm going to pour this into the leaven. I reset my scale to 0. I don't want to overshoot the target. You can pre-measure this if you're not used to using the scale, because once you go over the target, you can't go backwards. So I'm just monitoring this as I'm pouring. I'm up to about 500 grams. $600. I get to about 670 and I slow down. See, I'm actually at 690. I tried to stop at 670, 694, 700 exactly. So we added 700 grams of 80-degree water to the leaven, and now we're going to just stir this up to dissolve the leaven into the water. Again, this is where all the magic happens. The leaven is the yeast, lactic acid bacteria. This is what's going to do all the work over the next couple of hours. We're just coaching this stuff along. There's not a lot that we're doing here once we add this in. So that's why the leaven is so important, and hopefully this batch will be a good batch. One of the other potential problems with the leaven not working is if you have a weak starter. So that happens sometimes with new sourdough bakers, is you'll create a starter and you've been going for about a week and you decide that you want to bake some bread. You get impatient, so you try to make bread with a fairly weak starter, and that will cause the leaven not to rise properly. I don't believe that was the case here, because my starter is a couple of months old. It's very consistent. It doubles in volume every 4 hours. In fact, I have a video showing the starter doubling over a 4-hour period. That's the actual starter that we used in this batch. So I've sufficiently dissolved the leaven. There's still a couple clumps in here. I'm just going to reach in and break these up by hand. You really want to make sure that that's dispersed, that you don't have clumps in there, because the yeast can't swim. So you really want the yeast and the lactic acid bacteria as dispersed as possible in the dough, because if you get a big clump of them together, they're just going to eat all the food around them, and you really want as much dispersion as possible. So that's pretty broken up now. That looks pretty good. Now, we combine the flour. So we have 1,000 grams of flour per the recipe, 900 grams of white, 100 grams of wheat, and this will make 2 loaves. So we're making a double batch here. This is what's called for in the standard recipe. What I like to do is put in about half of this, stir it up to try to absorb some of the water so you don't get giant clumps of flour. Let that dissolve. I'm seeing a lot of bubbles in here, which is a really good sign. A lot of activity in the leaven. I think we're going to be good. Add a little bit more. Stir that in. You don't want to just dump all the flour in at one time, because you just get a big ball of flour in the middle of your water. That's becoming pretty shaggy. I still have quite a bit of flour left. So now I'm going to go to change my tools here. Scrape off the spatula. This is a tool called a bowl scraper. These are handy to have. You can pick up a pack of 4 or 5 of those for $10 on the internet. They come in different sizes and different shapes. So now I'm folding the flour into the water. This is really dry, so you have to really work this quite a bit. But it will absorb. There's always a temptation here to think that I need to add water to this, but you do not. Just keep working it, and eventually the flour will all be absorbed into the water if you measured things properly. And this is a really what's called a shaggy loaf, or a shaggy ball, is the telltale sign that you got the ingredients right. If this is really soupy, it means that you added too much water, or you didn't add the right amount of flour, you added too little flour, or you added the double batch of leaven. This would be very soupy. But when you see this shaggy ball, you just want to get all the raw flour off the sides. You don't want to work this too much. You're really just trying to hydrate the flour. You can feel it with your hand. The dough is starting to get sticky. So I see that the water. So I've absorbed all of the flour into this shaggy ball. It looks pretty good. Work it a little bit more. So we're just trying to make contact between all the flour and the water. You don't want any dry patches of flour in the dough. So there's your shaggy ball. That's really what that's supposed to look like. Doesn't look very pretty, but that is what it's supposed to look like. Get a lot of dough off your hands. Also, just a note, be careful when you're washing your hands in the sink. You don't want to wash a lot of dough down your drain, because it's like cement. So try to wipe your hands off on a rag or a towel or something before, or just get as much of this into the bowl as you can before you wash your hands in the sink, because you want to keep as much of that dough as possible out of your sink. Okay, so this is now called the Autolyse process, which is essentially adding the flour and water and letting it sit so that the water can start to release the enzymes in the flour. Technically, autoleasing is when you lease a car instead of buying a car. but the Autolyse process is usually just flour and water. In this recipe, the tartine recipe, we've also added the leaven to this mix. So this is actually technically a Fermentolyse, which is the Autolyse plus the fermented leaven. But it's accomplishing the same thing. It's just starting the activity of water absorbing into the flour and starting the bulk fermentation process because we've added the leaven as well. So we're going to let this sit, according to the recipe, for 25 to 40 minutes, and it's about 10:10 a.m. So I'm going to make a note of that in my cheat sheet here. We'll be back in, let's say 30 minutes. We'll check this. So before we cover this, I like to take the temperature just to see where we are. We added 80-degree water to probably room temperature flour, and this is a great temperature right now. It's at 79.4 degrees. So that's right in the sweet spot. We want to cover that, make sure that it's not no drafts are cooling it down. Keep it at room temperature. My room temperature here on my countertop is 73.4 degrees Fahrenheit, 22.9 Celsius. So this is eventually going to equalize with the room temperature, which is lower than our desired temperature between 78 and 82. When we come back in 30 minutes, we'll talk about how we keep this temperature up in that desired range above 78 degrees Fahrenheit. It's been 30 minutes since we mixed our Autolyse, actually Fermentolyse. So this is our starter, water, and flour. Let's take a look at what we have here. The recipe calls for letting this sit for 25 to 40 minutes. We've let it sit for 30 minutes. I really can't tell much by looking at this. The dough relaxed a little bit, which it should do. But what I will do is test the temperature, because it's incredibly important from this point forward that we monitor our dough temperature at every step of the process. For the leaven to really do its thing, the dough temperature needs to be between 78 and 82 degrees. Right now we are at 77.9, so we're just on the low end of that range. So at this point, it's incredibly important to think about how you can manage time and temperature, because other than the salt, which is going in next, all the ingredients are in here. There's not a lot we can do with this other than manage time and temperature. So because the recipe gave me a range of 25 to 40 minutes, I'm going to take advantage of that time. I'm not in a hurry. I'm going to let this go another 10 minutes, so I'm going to push the outside of the range because my temperature is on the low end of where it needs to be at 78 degrees. So when my temperature is low, I want to add time. When my temperature is high, I want to take time away. But because I'm right at 78 degrees and my ambient temperature in the room is 74 degrees Fahrenheit, which is 23.4 Celsius, what's going to happen if I let the bowl sit here is it will continue to approach room temperature of 74 degrees, and then it falls out of the range of bulk fermentation, which needs to be between 78 and 82 Fahrenheit, which is 25.5 and 27.8 Celsius. So that presents another challenge for us, which is I need to find some way to bring up the temperature of the dough. So the way that we do that is by creating what's called a proofing chamber. So let's talk about options for proofing boxes or proofing chambers. So we need to get it within the target range of 78 to 82 degrees for the fermentation to happen properly. We need to bring up the temperature of the dough. We do that by creating a proofing chamber. A proofing chamber is basically an enclosed space in your kitchen where you can get the temperature slightly above the room temperature, usually about 10 degrees above room temperature or the target temperature that you're trying to get to, so that when you put your dough into that enclosed space, it helps bring the temperature up to the target range. It's basically a heated box. For me, what we're going to use is the oven with the light on, the heat turned off but the light turned on, and just the light bulb inside the oven will heat the oven somewhere between 85 and 90 degrees. So that works well for all the different options that I've looked at here. I looked at doing it in my microwave. Sometimes people can put the dough inside your microwave with the door ajar, which will turn the light bulb on in the microwave. My microwave doesn't throw off enough heat to bring the temperature up. And I know that because I use these thermometers. You have to, if you're building a proofing chamber in your kitchen or a proofing box, you absolutely have to have one of these thermometers with it so you know exactly what your temperature is sitting at. I have a warming drawer here below my counter where I tried this for proofing. It actually has a setting on it called proof, but this is more for doing commercial yeast-based breads. I put my thermometer in here. It was 105 degrees on the lowest setting that I could get it to. So if you have an oven with a proof setting, if you have a toaster oven with a proof setting or a warming drawer with a proof setting, be careful that you measure what that temperature actually is, because those proof settings are usually much, much higher than we need for sourdough. So there are other ways you can improvise to create a proofing chamber. You could put a cup of boiling water, fill this cup with boiling water, and I could put this inside my microwave with my dough and my thermometer, and that would bring the temperature up inside that closed space. You know, something like this, which is roughly a half a liter of boiling water, can bring the temperature up between 5 and 10 degrees in a fairly small enclosed space. I could also take this small pitcher of boiling water. I have 2 sinks. I could put it in my sink, and I could cover my sink with these 2 baking sheets, and I've just created a proofing box by using my sink and a cup of boiling water. So you have all kinds of options, and if you want to spend the money, you can actually buy a proofing box. They make these things for bakers, and it's a little plastic box that pops up. It has a thermostat on it. You set your desired temperature. You can just buy a proofing box, and then you don't have to worry about improvising something. First option is always to just see what your oven temperature is with the light on. Put a thermometer inside, let it sit for an hour or so, and if that gets you into that range of 85 to 95 degrees, that would work. But with all this talking, I'm running out of time, so I'm going to put this bowl into my oven for a few more minutes with the light on. And my temperature inside the oven is 86.9 degrees Fahrenheit. That's a little hot, but with the door opening and closing now, it'll go back down to around 84, 85. Our Autolyse / Fermentolyse process has gone 40 minutes. That's the maximum recommended time. So the next step in the process is to add salt. Always pre-measure the salt and leave it here in a very visible place. You might want to put a big sign next to it that says, "Don't forget to add the salt." For some reason, if you don't have your salt sitting out, you don't make a note, people get to this step and they automatically start the next step and they forget to put the salt in. It's just like a mental block people have. It happens all the time. So I always put my salt right in front of me to make sure that I don't forget it. So let's talk about what kind of salt should we use. A lot of beginners have a question about what type of salt should I use in my sourdough recipe. So like everybody else, when I started baking, I dug around my pantry and said, what do I have? I have good old Morton table salt. I have superfine table salt, known as popcorn salt. I have coarse sea salt. I have fine sea salt. This is actually ancient fine sea salt. I think all salt is pretty ancient. I don't know where you're really getting young salt nowadays. I have Himalayan salt. This is the expensive stuff, pink Himalayan salt, because it's pink and it's from the Himalayas. And I have kosher salt, which I use for a lot of other cooking. All of these salts will work in a recipe. What you want to do is consult the recipe and see if there's a recommendation. In the tartine bread recipe, Chad Robertson actually recommends that you use fine sea salt, so that would be this one, so that's what we would use. So all these would work. There's not that much difference in flavor. The main difference in the salts is the weight. So we're back to the issue of weighing our dry ingredients, which is important even with salt, which is a fairly small quantity in the recipe. This recipe calls for 20 grams of salt. So if I said, I don't need to weigh this in grams, I can just estimate off the internet. Alexa, how many grams of salt are in 1 tablespoon?
There are 18 grams in 1 tablespoon of salt.
18 grams in 1 tablespoon. I'm going to use a conversion factor. So if I have 1 tablespoon and I slightly round it, That should give me 20 grams according to that conversion. I'm going to use kosher salt. I'm going to do a rounded tablespoon, should be about 20 grams right there. You probably know how this is going to end. Let's put this on the scale. 15 grams. Same story as with the flour. You have to weigh your dry ingredients. Doesn't matter which salt you pick, you just have to weigh it. If I used this approximation of 18 grams in a tablespoon of salt, but I happen to pick kosher salt, I would be underweighted in my salt in the recipe by 25%. I had 15 grams when the recipe calls for 20. If I'm not weighing it, I wouldn't know that. I would only find out later because it would impact my fermentation rate and it would impact my flavor. So always weigh your dry ingredients, including salt. Okay, moving on. Now we're going to add the salt to the Autolyse. So I'm going to take that out of my proofing chamber. Now my internal temperature in the oven is 85 degrees Fahrenheit. That went down 1 degree because I would open and close the door. So now we're going to add the salt. The way that we add the salt, give me my 20 grams here, refined sea salt. The way that we add the salt, some people dissolve the salt in water first. I find that it actually spreads out better if you add it dry and then add water. We're going to add 50 grams of water. I preheated this water in my microwave to exactly 80 degrees. I'm just going to test that again because it's been sitting here on the counter for a couple minutes. It's very important that you get these water temperatures correct because that's what you have to impact the temperature of the dough. And this is light. It's down to 77.8 degrees, so it's a little bit low. It's the only way I can impact the temperature is through water or heat. So I'm going to heat this back up to 80. Okay, I've got my water to 80.3 degrees. You can be slightly over. You don't want to be under the target. The recipe calls for 80-degree water. I need 50 grams to mix in with my salt. I'm going to measure that here in a cup first rather than try to pour it into the mix because it's easy to overshoot on these small quantities. That's exactly 50. So the way that we add the salt is I usually take the dry salt, I don't put it in the water, and you want to spread it around as much as possible so you don't get big lumps of salt in any one place. So I'm spreading my salt fairly evenly, and then I add this water, same thing, kind of pour this over the top. That's going to help us dissolve the salt into the mix. And then we mix this by hand, typically. So I'm going to grab the dough and kind of fold the salt in, turning the bowl. The dough is pretty stiff, very wet now that I've added that water, but this is exactly how it typically feels. Turning, squeezing. So even though you can't see the salt in here, you have to do this quite a bit. Imagine, to get all the salt evenly distributed throughout the dough. Squeezing and turning. Do this little trick. Squeeze the dough down like this. This looks pretty good. It gets that nice kind of glossy look to it. It's mixed in well. Make sure you get all the bits off the edges here. A couple more turns here. You're not really intending to work the dough here. You're really just trying to get the water and the salt distributed. That looks pretty good. So now that I've mixed in the salt, we are officially starting the bulk fermentation phase. This phase, according to the Tartine recipe, takes 3 to 4 hours. And as I mentioned, the target temperature for this phase is incredibly important, 78 to 82 degrees Fahrenheit, 25.5 to 27.8 on the Celsius scale. So we're going to continually measure the dough temperature to ensure that we're within that range. Otherwise, we need to add time. So let's see where we are right now. That mixing by hand cools the dough down a little bit because it's exposing it to room temperature. So I'm at 76.2 degrees, so I'm below my target range. I've got to get the temperature up. The only way I can do that now, I don't have any more ingredients to add. I can't add any more hot water. So I'm going to use my proofing chamber, which is my oven with the light on, which is sitting at about 85 degrees. That'll start to pull the dough temperature up. Before I do that, I'm going to move this into a different container. So a lot of times you'll see sourdough bakers will put these in a tall square container when you do bulk fermentation, so it's a little easier to see if the dough is rising than in a bowl where it's basically spreading out and you can't really tell if it's rising just because of the kind of geometry of the bowl. So I'm going to put this in this taller container and I'm going to try to flatten that down so we can see where our starting point is. Because we will get a little rise during this process and we want to know how much rise we're getting. So I'm going to mark this with a piece of tape on my side, and this is going to go into our proofing chamber, also known as the oven with the light on. I am going to cover this with this plastic bonnet. You can buy these. These are called plastic food covers. They work really well. The reason I use the plastic now instead of my favorite towel there is because I want to see what's going on, so I can see both when it's in the oven and when I take it out. I can get a little better picture of what's happening here. So I'm going to put this into the proofing chamber and I'm going to put some tape on it off camera. Sorry, I'm back. I put the tape on this and realized this actually doesn't go back into the proofing chamber yet. We need to start our stretch and fold process. There's no resting time between adding the salt and starting the stretch and fold. I thought there was, but there is not. So we're going to start the stretch and fold process. This is really the next major phase of the dough making, and this is the most hands-on work that we need to do. So we're going to turn, stretch and fold the dough at least 4 times, maybe 5 times, with 30-minute breaks in between each one. This is what's recommended in the recipe. I'm going to do the first one so we can get this in the oven, and then I'll talk about why we're doing it and how to do it. So basically, with the stretch and fold process, you want to reach down to the bottom of the dough, pull it up and let the gravity of the dough kind of stretch it. You don't want to rip it, and then you fold it over on itself, turn it 90 degrees, reach down to the bottom, let the gravity stretch and fold, turn 90 degrees, reach down to the bottom, let the gravity stretch and fold, and the 4th time, so I'm turning 90 degrees each time, stretch and fold. That was a pretty rough process. The dough really hasn't taken shape yet. It'll start to firm up and take some shape over time, but we're really starting to just create some elasticity in the dough by doing that. So now I cover this with our bonnet, and we put this in the oven for 30 minutes. With the light on, heat off. Set my timer for 30 minutes. This is where you have 30 minutes to kill. This process really takes a lot of time, and there's a lot of waiting time in between the next 2.5 hours. So this, when you think about your sourdough timeline, this is the time where you have to be kind of hanging around in these, you have these 30-minute breaks that you need to adhere to, 30-minute time slots for stretch and fold. So think about something you can do in 30 minutes, and I'll see you back here in 30 minutes.